Okay, click and close for like literally, I'm going to say 4 minutes and 17 seconds is my estimated time. Close them up. Close them up. Look up here real quick. I'm going to add just one very, very, very short assignment. I don't think I ever made you do this. I said I was going to. I want you to just get a little practice so you remember how to do it. So simple. I might have given you one problem like this, maybe. Can't remember. Where you have to just use Desmos. So all you're doing on this, I just want you to get used to, using this technology because we're going to be doing a lot of that in the future. So we're just going to use Desmos to, like for example on this one, where is that? Right there. Okay. So all we're going to do on a problem like this, where they're asking us, if you read through this, they give us some model. Production cost for widgets is given by the polynomial here. So C, capital C stands for production cost as a function of X, and they define X represents the number of years after 2005, right? And here's the polynomial they give us, right? They want you to use that model. It says rounded to the nearest dollar. The model predicts a production cost of blank dollars for the year 2009. So here's my function, right? There's the function. I just transcribed that, right? There it is, C of X. What would I do to get the answer? I'm going to evaluate the function at x equals 4, right? So I'm just going to do C of 4. And so my answer is, you can see down there, let me take a picture of this. So there it is, 65684.4. So what would I input? To the nearest dollar, right? So there's no decimal point. So I would just input 65684, right? Make sense? Okay. So then the other thing would be problems like this. So find all real solutions of the equation and round solutions to the nearest tenth. So all we're going to do is something like this, remember, when we're using technology, there's a couple ways we can do it. We could add 1/2 to both sides and find the x-intercepts, right? Find the zeros. Find out where it equals 0, which would be where the graph crosses the x-intercept. I don't prefer that method, though, because you actually have to do something and you might make a mistake. What I would suggest instead is that you just do this. You just graph the two. So we're going to graph whatever's on the left side of the equation, graph that function. Whatever's on the right side, graph that function, and just look for the points of intersection. So there's one, and there's one. They want us to round our answers to the nearest tenth. So in other words, you can use technology. So here, I'll take a picture. Oh, okay. There. Oh, I can do it. Oh, darn it.
He's choking.
I'm choking under pressure. There, that's better. Okay, so then what are my solutions? What am I going to input in the Moodle? 1100. So I'm looking for x coordinates, right? So one of them is going to be 2.8 and the other one's going to be 9.2. Okay. Now what happens, there is kind of a cool little trick you can do to Desmos. If I instead, watch what happens if I just graph the equation the way it's written. So it was just written as that stuff equals that stuff, right? And let's make this, whoops, let's make this red. Okay, what's it do? It's giving me vertical lines, right? But the vertical lines, notice that they intersect the two functions at the point of intersection, right? So it's literally graphing the answers, x equals 2.838 and x equals 9.162. So if you do set it up that way on Desmos, if you just literally write the equation in Desmos, it's going to give you vertical lines with the x-intercepts that are the solutions. What I don't like about that, though, is you don't get a visual representation of the curves, and what happens, for example, if there were no solutions. Like if I pull up one, like let's say y equaled instead, what if y equaled 5? Now notice, let's make it y equals 3. Now there are no intersections. And so if I graph this thing down here, I just don't see anything. And so maybe I think I have to zoom out forever to find them. And, they're not there, right? So it's a minor weakness, but I really do think it's better still just to graph these two things visually. And if I don't see any intersections, then that means I've got no real solutions. And that's what it's looking for, are real solutions, right? So, if we were looking for imaginary solutions, this wouldn't work, right? It's only going to give us the real solutions. Right. Okay. Good? Go. Work. How'd I do?
2 minutes and 10 seconds.
Oh my goodness. Okay. Well.